Hello, lovely people. How are you doing? Welcome back to our second part of our trigonometry compound angle formulae video series. So, here this question says express the following as a single sine, cosine, or tangent. So here we've got cos 130, cos 80, minus sine 130, sine 80. So if we call this A, and this B, and this A, and this B, we have cos A, cos B, minus sine A, sine B. This is the expansion for cos of A plus B. So therefore, that's the same thing as cos of, well, A was 130, B was 80. So this is equal to cos of 210. And that's all they wanted from us. That's all we'll do. That's what we'll do. So remember, if you're doing the A-level specification, then this will be, or the A-level course, should I say, then this will be on your formula sheet. So get familiar with these formulae. This one, tan 76 minus tan 45 over 1 plus tan 76 tan 45. So if I call this, in fact, a different color, if I call this A and this B, then this is A and this is B, and I end up with tan A minus tan B over 1 plus tan A tan B. And this is the expansion for tan of A minus B. So this is tan of, well, A was 76, B was 45. So that becomes tan of, well, 76 minus 45 is going to be 31. Okay, let's move on. Express the following as a single sine, cosine, or tangent. So, same thing. If I call this A, this B, and this A, and this B, I have cos A, cos B, plus sine A, sine B, cos A, cos B, just because it's what we're used to seeing, plus sine A, sine B. This is the expansion for cos of A minus B. But A was equal to 2 theta, and B was equal to theta. So this is just the same as cos of theta. That's it. Next one, same kind of thing. So we've got here A, B, A, and B. So this is cos A, cos B, minus sine A, sine B. And this is the expansion for cos of A plus B. So A was equal to 4 theta, and B was equal to 3 theta. So this becomes cos of 7 theta. Okay, let's move this question up because there's a bit of space. Now with this one, same thing. So again, I'm going to call this A, I'm going to call this B, and I'm going to call this A, and I'm going to call this B. So this is the expansion sine A cos B plus cos A sine B. And this is the expansion for sine of A plus B. Okay, and A is a half theta, so it becomes sine of a half theta, and B is 2.5 theta. So that overall simplification becomes sine of, well, 2.5 plus 1 plus a half even is 3. So that gives us 3 theta, like that. Okay, and we've got our last example, which I'm going to write in blue. That actually not blue. Let's go red again. So I've got a over here, b over here, a over here, b over here. So this is tan a plus tan b, all divided by 1 minus tan a tan b. And this is the expansion for tan of a plus b. A was equal to 2 theta, so that's tan of 2 theta. B was equal to 3 theta, so this becomes tan of 5 theta. There we go. Okay, let's do this one here. It says express the following as a single sine, cosine, or tangent. Same kind of thing. Instead of using a and b though, because a and b are already in the question, I'm just going to use x and y. So bear with. So x, y, x, y. So I end up with sine of x cos of y minus cos of x sine of y. And this is the expansion for sine of x minus y. So x was equal to a plus b. Y was equal to b. So overall that simplifies to sine of a. Okay, did say we're going to do one more, but let's just do one more, and I promise this will be the last one. This one looks complicated, but is it? Is it? Well, we'll see. So, going to call this A, going to call this B. So 3x plus 2y over 2 is A, 3x minus 2y over 2 is B. So this is the same A, and this is the same B. So this is simply cos A cos B minus sine A sine B. And lo and behold, that is the expansion for cos of A plus B. But remember, A was equal to 3x plus 2y over 2. B was equal to 3x minus 2y over 2. And just adding these fractions, I end up with cos of 3x plus 3x, because I can add them, they have the same denominators. That's 6x. 2y and minus 2y cancel, so that's 6x over 2. And that is the same thing as cos of 3x. Okay, now I promise this is indeed the last question, and we will look at the rest, or some more of them, should I say, in our next video. Take care for now.